guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show.
A team of highly trained scientists and others came face to face with a terrifying reality that, on superficial examination, appeared to break the laws of science, but that, in fact, was consistent with modern-day physics. At the ranch, scientists found a world where a great deal of activity was hidden from visible sight, but, as the researchers soon discovered, was detectable with state-of-the-art instrumentation. The family that lived there came to believe that the ranch was occupied by some kind of intelligence that appeared to control, as if on a whim, human perception, human thought, and human physical reality. The ranch in question lies well off the beaten path in a remote, rural corner of Utah, but is only about 150 miles from metropolitan, sophisticated Salt Lake City. The location is in the midst of a devout Mormon community and is contiguous with a Ute Native American reservation. Both communities have experienced unbelievable but well-documented phenomena in their midst for more than 50 years. In the case of the Ute tribe, the experiences are documented in the tribe's oral tradition stretching back over 15 generations. The account you are about to hear is true. I know because I'm
listening to an Audible book about the Skinwalker Ranch, which apparently everybody in the universe knows everything about. I know nothing about. So by the end of this project, I will have listened to the 10-hour book. What we got here is a straight 8 pill. And what I have been tasked with is turning this into a 16 pill. And what my customer has sent me is 2-part Sweet 16s that have got 4 Toshibas in each one of them to help offset the monumental cost of over $1,000 worth of transistors. So now to make this work, I basically got to completely take this amp apart. What we're talking about is the difference between a little bit of work, like basically the energy of building an 8 pill, versus building just a straight up 16 pill. I gotta have the sections match up, right? Well, because the people at Fatboy are smart, they utilized the full length of the heatsink. Instead of stacking everything at one end of the cabinet, they put it in the middle. Well, for me to expand this, I could put 2 and I could put 2 here, right? And I gotta get rid of this sideband delay horse shit that's in here. It's all gotta go. It's gonna turn directly into a comp box. For me to get around this, I've got to completely detach this 4-pill section, slide it over 2 slots, and then reattach it and resolder everything down. Same thing here. That way the 2 output sections will match each other. Otherwise I'm going to have splits, and I don't want to do that. And I don't want to go through all the hassle of unwinding and rewinding everything. Make sense? That's my mission. These power wires are woefully inadequate. I got some friends out there that they play a drinking game with how often I say that in the video. I think it's kind of cute. So that's what I'm going to do first, is move this down and turn this into just a regular straight 8 pill. But all this sub-architecture's got to come out. This has got to change. That's not big enough. It's woefully inadequate, by the way. Yeah, basically you got to strip this down, pull this down, move that over. And then we'll come back around and we're going to strip parts out of here that we need. And I think these are mine to do with as I wish. After that, I see their future. They shall be born again. We'll rise them from the ashes of the chop shop and we'll make them do something fun. Okay, that note, this is what I'm going to do. You guys are up to speed, and away we go. Well, this is where I left off last night. This is basically what's left of your amp, man. It's a little thinned out, huh? Have faith. There's a plan. So we're going to go ahead and we're going to move them sections down. This is where I need to call you on the phone and find out what you want to do for power wire, because this is not the way we do things around here. But we'll make this work unless you want to, you know, if you don't want to change it, you want to leave it the way it is. I don't know why I so carefully took them sections out. I got to completely rip them down and start over on most of them to make them up to my standard. So, but it's okay. We're going to have fun. This is going to be a fun little build. So let me get you on the phone, and then I'm going to proceed forward with getting this thing finished. We're going to get each one of the 4-pill sections down, moved down, and soldered in. Get all this stuff changed here. I'm heating up the big iron so I can take this off in one fell swoop instead of having to peck at it for a while. And then we'll start stripping down your Texas Stars over here. And we will turn them into something beautiful. I called my guy. He told me to go at it. He had a little bit of money to the budget. And he says, I want power wire upgrades. I want power wire upgrades. I want everything. I said, okay. So we stripped it down. We changed the power distribution bus down the middle of the box. And now we're going to get some serious power wires going on into this thing. So it's not too restrained trying to drink through the straw. Or to those of you that live in California, not so restrained trying to drink through the hollow tube. Because straws are illegal. They're like trying to hump unicorns in California. It's bad. So anyhow, change my analogy to be PC correct. Anywho, yeah, protection diodes in, a little bit of RF suppression capacitors are in, board's all drilled, everything's soldered down. So the next thing is we got to clean up the pill pockets, which we'll probably just pop the the heat sinks off and wipe them down, put them back on, and then we're going to slide and start reassembling our amplifier back on top of this. Away we go. And by the way, the book, I spent the last chapter and a half learning about Native American. I don't want to get into it. I'm just focused on what happened at the ranch and what the NIDS team figured out. I appreciate the backstory though. I do. Okay, well, back to the story at hand.
Mutilation case.
Where we go. Okay, so we got this 4-pill section and this one installed. We got all the transistors out of the Texas Stars. I got to straighten the legs out on them, clean the thermal paste off of them, and then I got to test them, which I guess I should do now. Hold on a second. $54 is a seriously good transistor. $48. Another seriously good transistor. Now one of these I kind of question a little bit. I'll explain to you why when we get that far. You get used to seeing these things, right? So you stare at them day in, day out, day in, day out, day in, day out, day in, day out. 63. That's a good. God damn, that's a good transistor. And you start to see, you see little differences, and you're like, whoa, wait a minute. So all you got to do is eat shit and breathe this for like 7 years, and you'll start to like think like a crazy person. Oh God, 59. Those are good. Okay, so I Haven't had a chance to clean up the legs on this one or straighten them out or anything, but 15, not so hot. Still totally viable. Just got to make sure to totally put that with another matched part. Here's what I'm noticing. It involves these two transistors. Just small observational differences. They came out of the box this way. So it's got an 11. 11. It'll still run. Focus. What we're taking notice of is I've seen thousands upon thousands of these transistors. The Toshiba is always a little bit darker. Over here it's light, and the transistors labeling is shifted up and to the right. Now, we've seen this before, and I cringe to say where we've seen this before, but it's truthful, we have seen this before. You've seen me reference this in other videos about the fake 2879s. Now, the differences are there in the print. Now, what we can tell the difference between a real 2879 and a fake one is they haven't figured out how to copy this material here yet on the base. This is a real Toshiba. This is slightly less translucent, or it's a little bit more translucent than the lid. Well, we have a real base here. And then the other thing we've noticed is that there's a tab that's right here, so when you tighten a screw down, it forces the transistor flat. Well, this one also has that tab. Now, these are all the same part run. 1E. 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 So that doesn't necessarily lean us to the idea that these are fake just because the paint's on there. Maybe they had a run issue, like where this one, as it was coming down the assembly line 20 years ago, it maybe wasn't sitting perfectly square in the holder. And there's lots of tests that we can do, but I have a good feeling that this is a good part, isn't legitimate. But when you see one that's printed like that, it's pretty obvious it's slightly different than the rest. You know what I mean? And them Japanese are kind of nitpicky, but maybe one slipped through the cracks. $18 par for the course. It's actually the highest gain transistor out of the 4 so far. Now what I'll do is I'll blow the thermal compound off of all 8 of these. 30. Woo! That one was paired with that one. There's no other transistors that had a gain of 30 that were in there. Anywhere close. It's oddly interesting to me. They test good, bottom line. So let me get out the electronics wash, which you guys have seen me do 1,000 times, so I'm not going to bother videoing it. Clean up the transistors, and we're going to get them mounted in. I screw them down to the heatsink, and then we're going to start building up the circuit around it. Sorry, I'm just not really into this today. You got a lot of really hard things going on in the background that you guys don't get to know about, but this job is not as easy as you all think. It requires dealing with a lot of very interesting people, and sometimes their point of view is very destructive and hurtful, but just take it all with a smile. We'll press on. We're going to get this puppy finished, and then it's on to the next project. Like I was saying earlier, this will probably be the last transistor amp you see come out of here for a little bit, at least a couple weeks. I got so much floor space taken up with just tube amplifiers that I need to really buckle down, and I need to get a whole pile of these SP220s, SP221s, and Henrys that I have sitting over here. I need to get them out of the way and get them done, just so I can have the floor space back. And then I might be able to open the doors back up to being able to take on more repairs. So, okay, that's our goal. That's what we're going to do. That's our timeline. Oh, and on a side note, when I went to pull the ground wire off of here, I heated this whole thing up with the 7 million watt iron, and when I pulled the ground leg off, it flicked. And I have found globs of solder, and literally you could hear it just kind of like rain down. There's a big glob of solder up here on the thing, and then I got a glob of solder right here. And then there's another one over here. And solder all over the front of the bird meters. I literally just took the board and I hung it over the trash can with the solder iron and just heated up the solder and just let it flow off into the trash can. This was all just globbed down. I have no idea why. They ran the ground wire through and hooked it up over here and had it hooked here. That's not what we're going to end up doing. We're going to make it a little bit more traditional style. But if you guys spot solder on stuff, that's why it flicked off in the production of this. And see, I've got, as I'm standing and looking to you, I got solder over here on a wall. There's still solder all over this, and a little piece of solder on top of the meter. I'll be hunting that now for a couple days, I'm sure. Okay, let's quit talking and let's do more. What do you think? I think I should. Okay, let's do it. Bye. Okay, real quick. I'm sorry about the noise of the fan in the background. I normally turn it off, but it is like 100+ degrees outside today, and if I do that, the house is going to get super hot. So, listen, this is where we're at. 4-pill output combiner's in, 4-pill input splitter is in, this whole 4-pill section's in, this whole 4-pill section's in, output transformers in play, metal clads, all new 5-watt resistors installed, new input splitters, new output combiners. I use metal clad capacitors on each one of the output circuits to make it last. The best parts that we can put in there. I've got to put the input or the output network in. I'm going to have a tuning tube here and one here for the input and output so we can get those zeroed in. And now the next step is we're going to install our power wires over from our new bus bar over to each one of the transistors. So get that going. We'll slam this thing inside the cabinet. We'll get it tested, tuned, and locked down, and then we'll go ahead and we'll shoot it with some clears. So on that note, I'm going to spend the next 2 hours working on installing power wires and network. Okay, guys, here we go. Well, here we are once again. So I start playing with this thing the other day, and we're talking, what was it, Wednesday, and you'll never guess what happened. First off, I had to go in here and I had to change a few of the windings. Like I had to change this here and change this here. I had the wiring too small. And then I found I had a couple little small components that weren't soldered down. So that's normal when you're fletching out or you're running out an amp that you just completely built up from absolutely nothing, basically. Now, if you guys can remember back from a couple previous segments ago on this particular amplifier, I was questioning the legitimacy of these two transistors, specifically this one. Well, excuse me, I was running this thing, and this section keeps dragging. This little 4-pill section here, let me pan back out again so I can put it in perspective. This section is independent to itself. It's a 4-pill section, and this little section is independent to itself. It's a 4-pill section, right? This particular section kept showing up over here in the output combiner as dragging. And that piece of coax, so we follow it around, goes to right here. No, wait a minute. Goes to right here. And these two resistors, this one was getting incredibly hot, but it would only get hot on this side of the resistor. but it was causing imbalance across all three of these. Well, I went and I checked, and these metal clad caps that I'd put down here at the end, I had one that wasn't soldered down right, and it was only, this one was at 199 puff or whatever, and so I went through and I had to change out a couple of these metal clads I put in here, and now that's all balanced. So I come back, and now the heating issues that I had going on in these other sections is in balance. The only problem we have is right here. This direction on this resistor and this direction on this resistor, and I can only see that with the FLIR, so that tells me that there's still a problem here. Well, I'm like, okay, let's run it up and see what happens. And so I run the power up, and as soon as I got up around 4,000 watts-ish, I see this little spark that took place right over here. And it happens to be from this transistor. And then all my power dropped off. Fell off to about 2,200 watts. Okay, I popped a pill. Which one? I want to know which one. Well, as I was looking at it, when I was running it up, we had some arcing and sparking take place from this section of this 4-pill section, this 2-pill section now, this 4-pill section. Seeing a little bit of arcing and sparking going on. So, I called the customer. I said, man, I am really questioning the legitimacy of these transistors. So, we've seen this before. I'm going to give you another example, but I want to really scooch in here close, and I want to look at this. These are all the same lot number, and they have the right lead length on them. But I know for a fact that this transistor is bad, and I have a hard time buying that Toshiba had a misprint that bad. And if we look really close at this one, we'll see it's also not centered, and it's up over to the left. And this one has also got a little bit of a kick to it. So what I'm going to do is first I'm going to start out here. I know this one's bad. I'm going to pull this transistor out. We're going to take the top off, and we're going to go look on the inside of it. Because as far as I can tell, the rest of this amp is sound. I happen to have 4 more Toshibas here. Imagine that. So if we have to, we're going to go in and we're going to pull all of these. But first we're going to start right here. Oh, man. Hold on. I'll be back. Okay. One transistor. The other transistor. So now what we're going to do, let's just give this thing a quick test. Hold on. I'm trying to answer every phone call that comes in today. Plus I'm trying to video around my phone ringing, which is a joy. I'm here to tell you what. So what we're going to do now is we're going to give this sucker a quick test. And let's see, what do we get? We got a gain of 30. Hold on a second. Okay, so where are we here? Let's see. We're going to give this a quick test. And we have a gain of 30. And that's on its partnered transistor. This one that's also got the odd print on it, as we've seen. So now we're going to go over here and we're going to jump onto this other one that's over here. Let's take a quick look for it that. Yeah. The problem is when I'm on the phone dealing with one person, I'll miss 2 more calls. And oh my god. Okay, so I was just on the phone with D-Rail and we were talking about how hard it is to just try and stay ahead of the phone. And okay, so now what this is telling us is that the red-green leads are shorted. So no text, red, green. So these 2 leads here are shorted internally, but its paired component is at 30. Now these are all the same lots. We know this transistor's bad. It's the one with the way effed up print on it. Let's go ahead and get ourselves set up, and we can we'll burn the top off this thing, and we'll see what we can get. We'll take the top off of this thing, and we'll see what's going on internally. Because me personally, I am really having strong reservations about if these are real or not. You know what? I give. Voicemail. I understand it's Monday, and I understand Skip's rolling, and I totally get that. And I constantly have people calling me. I sent you my amplifier repair 4 months ago. Why isn't it done yet? Well, I told you in the beginning when you sent the amp out that it would take 5 to 6 months for me to be able. It's a good problem to have, but in the same breath, it's hard to manage. You have to be sensitive to the fact that the customer is just wanting to communicate with you, and they feel like they've entrusted you with a great deal of money, which is their piece of equipment, and they don't want to feel like they're getting blown off. In the same breath, we've got to be able to physically do the work. You know what I mean? That makes sense to everybody? So it's like, it's hard to explain to somebody that same person. Voicemail. Same person. It's hard to explain to somebody that you have so much work here that it's not realistic for you to try and give them some arbitrary number that when you're going to be done, because you don't know. This project here has taken me 2.5 more days than I wanted it to because of other things, outside influences. If I was able to sit down and just work on this thing straight out, I would have been done on it. But there's a lot of other interruptions that take place when same person calling me multiple times, because now they've realized they're going to voicemail, but they're demanding that they must have my attention. And no matter what, I cannot answer the phone being frustrated or mad. Voicemail. I have to give it a few minutes and then call them back and say, yes, how can I help you? And I have to be calm no matter what. It's a large trial of patience in a lot of different aspects doing this job, I'm here to tell you. But meanwhile, we're simply trying to work out if this transistor is fake or not. And we are going to get there come hell or high water. Excuse me a minute. Okay. It's Monday, and I've got to get this amplifier done. So, for you guys to be able to enjoy the cinematography, beautifulness of this, come on. There it is. Bobby dibble da knob doo boo boo. Look at that. Ignore phone. Ignore. Okay. That was a legit Toshiba. Alright. There's something else wrong in that circuit. I just thought it was very rare or very odd. Let's get down in there. Come on, camera. Get down in there. I just thought it was very odd that this one was the one that decided it needed to have an issue. It's the one that had the print up and to the right. Man, that thing come apart though, weird. Alright, it was legit. So I guess maybe there might have been some flaw with that transistor, I don't know. That definitely looks like the inside of a legit component to me. Let's, I've seen a few. Let's go over here to the giant bag of garbage. And let's see if we can do this again. It's just Monday. It's just Monday. Believe it or not, that transistor's bad, but it doesn't have any visual physical damage. And what we're looking at here on the inside of the device is not only just the wafer, but we're looking at our tabs, the way the tabs are put together, the internal structure of the transistor is put together. What we are missing is this ground wire that goes across. No, it's just burn up. This is burn up. That's a legit deal. They just had a misprint. Okay, well, now that we've thoroughly investigated that to the end of the eyeballs, let's get on with getting this thing repaired. What do you guys think? I'm ready to move on. Oh my god. Shall return. It's done. It's done. Oh, thank god. This is actually the next day. Now, you guys, I just gave up last night on trying to... Oh, you little snot monkey. Come here. I gave up yesterday on trying to get this done. I just decided to focus on the phone and to focus on some projects, and focus on a friend of mine that I had in town. I had the neatest thing happen last night. A friend of mine ended up having problems with his box, and I'm so proud of him. He called me on the phone and says, "Brother, we're having a problem." And I said, "Okay, well, let's work our way through it." You remember when I met this guy about 3 years ago, he didn't even know what a soldering iron was or how to use it. And with just us being on the phone, with the small assemblage of tools that he has on hand, he took his tube amplifier apart. We checked a whole bunch of stuff with a soldering iron, a voltmeter, some screwdrivers, and just general knowledge in what we were doing, like stuff that we had taught him. He completely disassembled his box. He figured out where his short was. Now, keep in mind, I had to stay up till freaking almost 1:30 in the morning helping him last night. Just talking him through what he was doing and reminding him, look at this, look at that, make sure this is off, make sure that this is grounded, that kind of thing. He took his whole freaking amplifier apart and put it all back together and got it running all by himself. And all he had to do was change one part. And it didn't have to get shipped nowhere. All he had to do, he paid attention. He paid attention and he's learned. And now, you know, as I talk to him on the phone, I'm incredibly proud of him because now in his little local radio community down there, these guys don't realize it, but he's literally mentoring like 5 other people. And every single one of them now have got, you know, over 3,000, 4,000, 5,000 watt stations, where he's at like the 12,000, 15,000 watt benchmark. You know, he's got all these different guys doing different things with their equipment and got them all up and running and introducing them into hi-fi and all this kind of stuff. But he's mentoring, and what has come from that is the radio community around him has grown and improved. And I was just sitting there last night in awe, watching him go. And he did this while he was semi-drunk, come to find out. It's like, what the hell, bro? So, okay, I'll teach you guys all something more here. This is what I clear the cabinets with. Just so you know. I don't use this stuff. Although you can do it. This is Rust-Oleum, okay? This has a tendency to go opaque after a while, and yeah, there's some other downsides to this, although you can clear your cabinets with this. This stuff is straight up epoxy. It's 2-part. It's got a plunger on it. And what I mean by a plunger is you shake this very, very vigorously for 5 minutes. The whole bottle. You shake it like like an 11-year-old kid for 5 minutes, literally. And you pop this pin out, this little plug, and you punch it into this end of the can. Top of the can, bottom of the can. Then with you holding the plug down with your finger upside down, you shake it for another 5 minutes. This is an active epoxy-based paint. It's also 100% non-conductive, which is cool. For those of you guys that wanted to know how I clear coated my antenna the other day for my mobile application, I got color matched 2-part epoxy paint, or what they call undercoat. Did 3 layers of that, where you mask off all the little important bits that you want to still have conduct, and like really conduct, that need to have surface pressure. Everybody's like, what the hell is he talking about? I'm talking about this. Oh shit, it's out on the truck. Never mind, I don't get to show you. I was going to pan out and show you the antenna. And then I did 4 coats of this. It comes out to be completely gloss. I mean, it is like glass. But literally all we got to do here is we're done. Just like that. And because it's epoxy, as soon as it makes contact with the air, it starts to harden. That's it. We're done. This thing's done. I've been watching a lot of YouTube videos lately on the RWB guys. And them dudes are some badass. That one guy, Mr. Kai, he is amazing. Gentleman out of Japan working on these Porsche cars. He's got some really neat kit parts that he puts to it, but it's not just the body panels he puts onto it. It's a full suspension thing, and he's been traveling all over the country and doing these things. He's just got a couple in San Francisco, a couple up in New York, a couple in New Jersey. He's got one in Atlanta. Beautiful racing cars, but to listen to his customers talk about what he's doing for them and these older model Porsches to modify their ride stance, and I mean, I get there's a purist out there. There's amplifier purists out there. What he's doing is creating a personal gift, a piece of artwork, and then giving it from himself to the customer. And I was really impressed with this guy, and it clicked in my head. And he's so humble about the way he does things. He's like, yeah, dude, I know that these are badass cars, and I know that, I'm one of the few people in the world that's doing these. And there's a lot of dudes out there making lowered cars, and there's a lot of dudes out there that are modifying vehicles. He simply goes and says, look, this is what I do. Excuse me a second. This is what I do, and I'm grateful to be doing it. This is what I do. I'm grateful to be doing it, and I'm glad that I have these young hands that are still capable of doing it for a short time. Everybody that has come before me, either they lose their eyesight, their hands start to go away, the knowledge is fresh and young in their mind, but their body is starting to fail them. And I'm proud that I am of the age that I am, that I'm able to do all these wonderful projects for everybody. And I'm grateful. Hence the reason the phone rings a lot. And it's frustrating when I'm trying to get something done, but overall I'm very grateful for all the opportunity. And if you want to see some pure artistry in car modification, go check out the RWB guys. It's really neat. There's quite a few good YouTube videos. I got familiar with the gentleman when he did the GoPro Japan video, which was neat in itself. So I watch YouTube videos like that to help inspire me to keep doing YouTube videos like this. Last thing, we're going to wrap this up and then we're going to come back to the end of this, because I'm done and we need to move it on down. When I started this YouTube video, I was listening to an audiobook about the Skinwalker Ranch guys. That poor family, the things that they went through on their little private piece of property back there, and the fact that they can document all this weird stuff's been going on now for centuries. There's so many different phenomenon taking place on that one little hunk of dirt. I feel for those people. I really do. They went through a lot of very hard experiences, and the fact that they were so well documented, I don't even know what to say other than I think that this is a bigger world than we could ever possibly imagine. I think there's a whole lot more to it than we could even remotely even think to understand right now, and it's arrogant of us to try and assume that we know everything and that we need to be more scientists and go out and explore more. That's all I'm going to say. And if you're into the UFOs or know the Skywalker Ranch or the Bigelow guys or any of them dudes, that's great. I do amps, and I'm not interested in anything other than the amps. Now, if there's somebody that works at EG&G that's out there, or knows somebody that works at EG&G, and they're interested in hiring somebody that's interested in wanting to figure out how to do radio communication and high-speed data transfer inside of a gravity well, I'd love to come play with that technology. I'm just saying, I would love to experiment with that, because I think that that is something that's going to come in very handy in our near future as a civilization. So, inside of a gravity well, by the way. Okay, on that note, I usually go through about 4 books a week, by the way. Just so you know. And it's on a huge variant of topics, but most of them are engineering, nuclear power, mechanical design, theoretical design, electrical theory, that kind of stuff. You should see my Audible book collection. It is long and vast. So, okay, let's close this up and let's get this done. I'm ready. I'm really quite ready to be done here with this guy. It is done. Oh, one more thing before I go. One last little bit. Let's go over here to the welder. The welder. There is a neat Nova program about the building of an oofbird. So it's also known as the Great Viking Sword. And the master metalsmith that they use that explains some of the best swords ever made in the darkest period of our overall world history. He sits there and he goes, it's not that he can't do anything. He's explaining to people the love, his drive, and his passion for what he does. He says, it's not that I can't do anything else. This is a master in metalworking. He says, it's because I can't do anything else. It's not because I can't do anything else. Seriously, I don't want to do anything else. It's a shame that I can't get a cabinet made of clear aluminum. You know? Well, there's some YouTube videos out there. I question the validity of what they were doing or what they're claiming. You'd never know. There's so much energy and love that's gone on the inside of this box. But looking by the outside of the box, other than that sticker. Brother, we managed to salvage the one fan that was busted. Let's see. We probably don't have a good enough groundage going on. What do you think? I think so. I don't think we got enough groundage. We have successfully taken your 8-pill, stripped down the 2 Texas Star 667s, and built you a beautiful 16-pill. Sorry it took so many days to get done. Between the holiday, the 4th, my other job that I have to keep, I just have to keep it. No ifs or buts about it. And all the other stuff we've had going on over here, plus customers coming to town. Sorry it took so many days, but it doesn't matter. It got done. So let's start running around the lap here, and let's go through the paces of things. Okay, it's a 1,000 watt slug in 5X, 1,000 watt slug in average, 5 watt slug in reverse, and then sitting between our driver amplifiers, which is our bench 2-pill, bench 4-pill, and 50 watt slug sitting between the 4-pill and the 16-pill. Now guys, I am like the rest of the clan. And let's go down from the top. Dave made X-Force, Fatboy, Okay, every major manufacturer still left. The Foxy guys aren't building anymore for a moment. Hopefully Christine will come back and start building again. The Prime Minister Dominator, that school of thought. All of my boxes are tuned with the 1, 3, 6, 9, 12 foot rule increments. Okay? So all the comp guys tuned by. Everybody has got the standard lengths of coax. So 1 foot to 1 foot to a 3 footer. So 1 foot, 1 foot, 3 feet. Or otherwise 6 feet will also be resonant, 9 feet will also be resonant, 12 feet will also be resonant. Okay? You follow? It's like this jumper here, 12.5 feet. All of these, like 12 foot long, all these jumpers, for a reason. So we can have a form of standard between all of us. So now, let's run down the list. We're going to take the 2950, and here's our 5 watt slug between the 2950. That's the other thing. I was listening to these guys chat about me the other day, and somebody said, man, he got way too many damn bird meters. I don't understand what he's talking about all the time. The reason I got all the damn bird meters, guys, is so that I have a fixed form of measure on everything. The jumper lengths never change. The placement of the meters never change, and it allows you guys to have a little bit more flow and form to your train of thought when you're watching these videos, and understanding that when we're looking at this meter, how it says IC 7300, or we're looking at this meter, it's the SRS 490, 2950, 2950. That's the one for the D-Rail radio. They never move, they don't change. The elements that are in them are never a variable. Now, if it was up to me, you guys, I would have these line sections remoted out all over the place. I'd have 316 coax running off to wherever they needed to be, and I'd have one big giant panel that I'd have very clearly labeled what all the meters represented. But I think that's very confusing for people to look at visually on video. That, and it lends itself to there to be some tampery taking place because you can't visually see the element. There's a reason why I simply go, let's go around the band, and I show you this is a 1000 watt slug, this is this, and this, and this, and this is this, and this is this, and I show the placement and I show the coax going in and out of them. It's to help have a benchmark and a standard. Hence the reason 99% y'all other builders, your benches are now built like this, because it made sense as soon as you see it. Yeah. There's a reason there's a lot of bird meters. It's the only one anybody even trusts. Now you can take almost every other meter in the market and make it read exactly the same as a bird. Just saying. But it's... So yeah, I got a lot of bird meters. A lot of them. It's only about maybe 2/3 of them. But at least we know our equipment's getting measured accurately. Let's grab our microphone for our 2950. And we're going to look up here, and what we're measuring now with this watt meter is the amount of power that is coming back from our line terminus all the way over here, our 10,000 watt dummy load. But really what we're looking at is everything past that coax connector right there. So our 12 foot jumper of coax comes down, and then our RF has got to pass through this 2-pill perfectly. It's got to pass through this 4-pill perfectly. It's got to pass through this line section and through all the different connections, and then over to the 16 pill. Through the 16 pill out, through all the different coax connections and terminus points and stuff, and then come down here. That's what this meter is showing us right now when I say we're going to do a pass-through tune. So with 20 peak watts going forward, that's a 5 watt element. That's less than 1/10 of 1 watt of reflected power. It means we've gone through and customly tuned each one of these boxes, and every single pieces of this coax and all the ends that are attached here. It's all perfectly in resonance with the RF. So the RF is flowing with the least amount of resistance we can have as a unit of measure through all these different connections around down to the terminus and getting sucked up by the terminus and turned into heat. It's important because now that represents to you guys when you watch one of these videos At this unit of measure, means the RF is passing through these boxes with little to no resistance. Now there's still loss that takes place. That's a different unit of measure. What I'm showing you is the unit of resistance that is applied to the signal of RF. Let's turn the amp on. Now, just barefoot with the radio. Remember, that's in the 5,000 watt position. Bring it down to 1x position. So with 20 watts of drive, and we know that because now we're going to show you what it's like with the amplifier off. This is in peak. Here's our 20 watts. Here's an average. Oh, that's already where I need to be. Turn the box on, ding-a-ling. With 20 watts worth of input power, half a watt of input reflag. About 750 peak watts. 200 bird. It's a 5 watt slug, by the way. No reflag. Input tune down here. Just a few watts. Okay, now we're going to shut off the 16 pill. And we're going to bring the 2 pill into play. That's our pass-through SWR. The RF going from the 2 pill, through the 4 pill, through the 16 pill, out to the dummy mode. There are 20 watts worth of drive going into the 2 pill on the 1,000 watt scale, which is the bottom scale, the 1 through 0, adding a 0. I'm going to put roughly 400 peak watts worth of drive into the 16 pill. That bird meter's going to the corner and disappearing. It's moving, just barely. So that tells us that that's truly measuring all the power that is leaving the amplifier going into the line terminus. And we're going to go to 2x. Let's just go down to 5. We're going to go directly to 5. So now we're reading this middle scale, the 10, the 20, the 30, the 40, and the 50. And we're going to add a few zeros to this. Total of 2. Okay, so the 10 is now 1,000, the 20 is now 2,000, the 30 is now 3,000. I think we get it. Yeah, it's 3,500 watts PEP. Look at it again. Now, if you dedicated your life to this, and you have spent the amount of time staring at your bird meters that I have spent, you would know that this is not a precise unit of measure, but if I was to have to place a gambling bet, I would probably tell you that this is making about 12, maybe 11,050 watts, maybe 1,200 watts worth of RMS power. No camera focus. Yeah. 5,000 watt slug, by the way. Just guessing, but that's not an accurate form of measure. So we're going to put that 5,000 watt element in the average spot. There's our drive. If I was a gambling man, and I'm gauging that just on how hard it's taking the needle and putting it into the corner. From the 100 mark, like if this is on a 1,000 watt scale, to the stop peg, if you're just lightly cresting the stop peg, is usually about 1200 watts. There's about a 200 watt past the 100, about past the end of the meter movement that you can calculate. And I can tell just by it running how hard it's running to the corner. That would be about 1150 to 1200 watts. But now that we have the 5000 watt slug in there, now we have a valid unit of measure. Now, let's take a quick minute and we're going to talk about bird meters real quick. People think of these as the pinnacle of measurement of RF power. They are not. This is just a general non-tampery watt meter that people have come to enjoy looking at because they know that usually the information that they're getting from the watt meter, unless somebody has managed to twiddly-dink with the inside of the slugs, is going to be fairly consistent and uniform universally, and it's going to give us somewhat of an accurate guess. The downside to the bird meter movements is the scale is not linear. So if we look and we see the space between 0 and 0 and the 10, the 5, the 10, and the 20 is not the same amount of distance from the 20 to the 25 or the 40 to the 50, the 80 to 100. That means the bottom third of this scale from here down, there's anywhere from a 5 to 15% inaccuracy. So when you're reading all the way down here, unless you have a very low valued slug, and slug is not the right term, the element, if you have a wrong valued element, a very low valued element, even reading down here in this end of the scale is not a very good form of measurement. There's quite a bit of deviation, but now they claim that when we get up here into this top third of the element, or the meter, that's pretty close to scooch 'em. Pretty close to on the money. Okay, so that being said, we're going to go use the bottom third of the scale. That's our 2-pill driver. Oh, shoot. I'm skipping some stuff here. Input tune. Three and a half watts of input reflect. I'll take that. I'll take that any day of the week. All right, let's kill the 16 pill. Now we're going to go back over here to the 4 pill. So now we got the 2 going into the 4. Okay, so we are now making about 1100 watts worth of drive. Now, the amount of performance increase that we're going to see from the 16 pill is shocking in how little it is. We're going to go from 3,500 watts to about 4,000 watts power because we've reached the match saturation of these transistors. They cannot produce any more power. They cannot turn on and off any harder than ever. The only way that you're going to get more power out of this is increase your voltage. And right now we're sitting at about 14.8, 14.9, somewhere in there. So about the max performance that you're going to ever get out of this is this 1 drive and 2. If it was me, I'd get a 1 drive and 2. Not the 2 drive and 4 setup. I'd get a 1 push and 2, which does about 500 watts, loaf it into the 16 and be done with it. They'll run forever like that. You'll get 3,800 watts. You got to put another 300-400 watts of drive, usually into most 16 pills, to get another 300 or 400 watts out. It's pointless. If you look at it on a graph, you get this huge RF power return and then it drops way off in its efficiency. But fully saturated, we got to show it. So with about 1100 watts going in. Oh, RF in the damn microphone. Now you notice we didn't see a huge increase in the average numbers, right? But we're seeing about 400 more watts out of the box. With 1100 watts going in, we're getting about 4.5 watts of input reflect. Otherwise, 1.001. Good enough. We can sit and twiddly fart around with this thing till the cows come home and get that down to like 2 watts. If 4 watts of reflect is going to hurt these boxes with 1100 watts, which is more drive than this box needs. Let's see, what's the term I'm struggling for here? You better go suckle on some Bruce Jenner tears and see if you can find a facial wax made of unicorn semen, because you're a special kind of loved individual. There we go. All right, hold on a second. Let me shut all this shit off. We shall return. I had this phone call yesterday, you guys. This gentleman calls me. He says, BBI. Yes, sir. He goes, man, I got a problem. I said, oh, yeah? And I've learned over all these years to just stay neutrally flat. Because normally when somebody calls you up and says they got a problem, that means something's going wrong, right? And usually most guys, they're calling you up to tell you that they're blaming you, right? And 9 times out of 10, we work through it and we find out it has something to do with their setup. Anyhow, this guy calls me yesterday and says, BB, we got a problem. I'm like, oh yeah? Now I got him saved in my phone. I know who he is, right? I know who he is. So I answer the phone. I'm like, hey, what's going on? Now, I'm not giving any names because we are protecting the innocent and guarding the liars. He says, man, I gotta send these 2 amps back to you today. I said, oh yeah, what's that, man? He says to me, dude, I had them son of a bitches stretched out like a friggin' dog on the side of a Greyhound bus. Oh shit. What he told me in that one sentence was, the boxes were running great. I was having a blast. I was running them really friggin' hard. And they frickin' failed, but I don't blame you. And all I could do was laugh. And this is like second to the last phone call I took yesterday before I just finally said enough and I had to stop for a hot minute. Which reminds me, I've got about 2.5 hours of phone calls I gotta finish today. I had to get this done. I gotta get this off my workspace. I've got to move forward. So, well, what happened? He goes, well, I was running the thing at about 18, 19 volts. And I think I stayed in there for too long because power dropped way off on it. I'm going to send it back to you. I want you to go through it. And I said, all right. I said to him, man, well, you know this really isn't my fault. He goes, man, I don't care. That damn box runs so good. I don't give a shit. I'm going to run it again, too. When you give it back to me and get it all running again, I'm going to run it like that until it breaks, and I'm going to send it back to you, and you're going to keep fixing it. And it's like, okay. I'm willing to do that as long as the customer's not trying to pretend like it's my fault for some silly reason. Oh, okay, Mr. R. Here we are, my friend. I remember when this came in here, it had tiny little piss-ass power wires on it that were about that long. And you said one of the major things that you wanted to overcome and get rid of was them short power wires. Well, now all you got to do is put a ground strap, preferably about 1/0 or so, between this and whatever your power supply is. You said you wanted to have approximately about 3 or 4 feet of wire. Well, we gave you about 5.5 feet of wire, and that's a lot of strands, buddy. It's a lot of wire that went in this box. We upgraded the power distribution on the inside, obviously. We totally disassembled the 2 8-pill sections on the 16-pill board, moved the 2 8-pill sections down, took your other amps, pulled the valuable parts out of them, built with those valuable parts, short of one, another 8-pill section, built you new splitters, a new combiner network on this thing, on and on and on. And listen to me, love on this box. A lot of time and energy went into this just for you, and this is a gift from me to you, for the most part. Created you a piece of art, treasure it as so. And I think a lot of guys actually are now doing that, because I'm not seeing a lot of my equipment that's out there get traded all that often, and when it does, it goes away pretty quick. People get the art, they treasure it, and they work with it, they appreciate it, and they keep it, and it runs like a Swiss watch. I'm going to wrap this video here. I'm a little bit tired of doing the, gentlemen, my name is BBI, and holding the camera up here. You all know my phone number. It's right here on the wall. It's at the beginning and the end of every video. I'm busy. I'm doing the best that I can as a one-man band. I don't want to grow. I don't want to be any bigger. I don't want to have 15 employees. I don't want to try and train anybody. The precision of this and the fun that I have with this would be lost. I'm currently not taking on any projects whatsoever. No new builds, no repairs. I'm working on what I have on the books, and there's a lot of it as far as repair work. I have nothing new left to build. I have these 4 amps I'm working on right now, and maybe a couple other little magical unicorn farts out there that I'm going to take care of here quickly. But I appreciate everybody calling and checking in and talking with me about stuff. It doesn't need to happen on a weekly basis because things over here obviously move fairly slow. Because remember, I'm just one guy with a lot of responsibilities, with 3 different companies I work with, 3 different things I do, and that's not even counting my first and most important job, which is my family. Appreciate everybody's patience. Thanks for tuning in and watching this video. We'll see ya.